it'll be easy for people to understand because I'll show the GitLab YAML file first and then look into the Docker container introduction.
Mhm. Yes, sir. Okay.
Okay, I'll start the recording. It is already started. Okay.
Yeah,
Share
I'll
it.
start.
Okay. Is my screen visible?
Yes. Yes.
So I have the gitlab.gitlab.ci.yml file. First portion here, variables that are required to run the pipeline, especially access key, secret key, we define it, and the region. Um, like I told you last time, we can configure these as variables inside our GitLab settings. That is, if you go to the home page and go to that particular repository, and then go to settings and CI/CD. If you go to variable section, there you can define the variables one after the other, like this: access key, AWS access key ID, AWS secret key, secret access key, like this. And the way to go to the pipeline is go to build and pipelines. After going to the project, you can go to the pipelines like this and the settings like this. Go to settings and CI/CD. And if you want to look at the code, you have to go to code and repository. And that will show the code. The GitLab-ci YAML file will have the logo, that GitLab icon. So like that, you can easily find out where this file is available, because this is the uh, base file which is required to run the pipeline. If you don't have this .gitlab-ci.yml file, the pipeline will not get executed. So few other things, fundamental thing. You can either define variables or you can leave it without defining also. That's not a problem. But you should have stages defined based on whatever jobs that you are going to run, whatever sequence that it is going to be. Any activity that you take, for example, say for example you're going to a swimming pool to probably have a swim for about an hour, right? The total process which is included in the completion of the cycle is called pipeline. Say you want to pack up your bags with the swim dresses and then start your bike and go and probably just check whether the swimming pool is open or not, whether they allow people to swim or not. Then you get into the swimming pool. So like that, there are different stages before you go to the swimming pool, right? Um, like that, if, for example, if you don't have the swim costumes, maybe if you don't have the bike ready to go out, right? Probably the pipeline will be halted in between, right? You will not be able to go further and then go to the swimming pool and take a swim. Like that, pipeline also has some deliveries. For example, we go with the infrastructure creation. For that, it requires 2 to 3 different stages like init, plan, validate, init, validate, plan, and apply. So these must be run in a sequence in order to achieve this completion of the pipeline. Like I told you, there are some stages which we need to execute manually, which is added with when manual keyword that doesn't get executed automatically because that's a destroy of the resources.
Mhm. Okay.
The plan apply are having almost same structure as we used to write. The first thing that you write it here, this is a YAML structure you must be knowing, and whatever you end with colon, that becomes a dictionary item key. Whatever is starting with the dash, it becomes a list item.
Sir, here it
Yeah.
only starts with validate, right? We don't need to give init.
Yeah. That's a question I expected. I'll explain it to you. So that's where we are falling into explaining Dockers.
Oh, okay. Awesome.
Your question is valid. So the thing is, if you look at line number 11 to 15, right? We are talking about image. Image is nothing but a Docker image. What is the image name? HashiCorp Terraform Lite. Lite is a tag which is there for Terraform Docker container, Docker image, and this is a path which will be used to run Terraform. So entry point is nothing but we are running the particular uh, uh, application, uh, the Terraform commands using this particular path variable, so that Terraform gets executed as long as it is available in the machine. So when we say HashiCorp Terraform in line number 12, that automatically pulls a Terraform container and that will have the Terraform installed. Only thing is we need to make sure where the Terraform executables are placed. That's why we are giving the path variable like this. And then user bin env is a command to get the path and run the Terraform command. So before script is something which is executed before any job is executed. See, if you go to the job, you will see that plan is validate is the first job and it has script. Script is nothing but a shell script or shell command which is executed on a shell prompt. So we are running Terraform validate as a first step. So this is to validate the Terraform code that which we have written inside the Docker container. And before script will be executed, before any job is executed. So it'll run Terraform init and then make sure it is available for you. Terraform is initialized successfully. The next thing we have is a plan. For plan, we have the dependency. If validate does not go through fine, this will not get executed. If the validate fails, it will fail. It will not go to the next stage. Artifacts is what file is created as an artifact. That is a plan file. Normally, what you see the plan, right? That is created and saved here. And we say dependencies plan. That is because we are relying on the plan stage. If the plan fails, the apply will not go through further.
Mm.
So if I go back to image, like I told you, it is a Docker container which will be used for running the pipeline. Okay. Anyone else? No one else joined. Okay. I'll just give you a couple of minutes to go through this particular file. Maybe I'll give you the file for you. You can take a look into it. I'll share the file for now.
Sir, actually, what's the main purpose of this file, gitlab-ci.yml?
Uh, oh, you're asking what is the main purpose of writing the CI/YAML file?
Yes, sir. Yes.
That is for automated execution of your pipeline changes. For example, you are adding a new EC2 instance, or you are changing the EC2 instance size or type, or the EBS volume. Once
Mhm.
you make some changes, it should be automatically synchronized to all the environments like dev, test, stage, and production. So that will go to a, I mean, the changes will be automatically applied to the different environments. Even if you want to delete a particular environment, you don't need to go and delete the environment. You just need to click on the destroy stage, and that will automatically be destroyed. Say, for example, I'll show you the build pipelines, which is already running, which is already executed. You can see that there are different stages executed. If I go to the pipeline ID, you will see that it is validate, plan, and apply. Destroy is not running because we don't have the destroy stage running at this point. It will not be executed because the I created it in code cloud that was already destroyed.
Oh,
Okay, just give me 2 minutes. I'll be back. Just have a look at this.
sure, sure.
Okay, I'm back. Okay.
Yes, sir. Yeah.
Okay. See, what you can do is I can probably share this file um, to you, and then you can get this added into your EC2 folder. You can start sharing a screen because some of the things, if you start explaining, um, I really need at least 2 to 3 people in the call so that I can explain with more confidence. Because I mean, I may have to explain it multiple times, so that's why I'm just thinking twice.
No, sir, but
Tomorrow,
the recording will be there, right? They can refer to that.
okay, sure. Then I'll go and then start with the Docker container so that I mean, you have a little better understanding.
Mhm.
Uh, I'll go with the slideshow. Nothing much we need to discuss in these slides. So currently we are at this particular stage. Whatever we have completed, I'll tell you. I mean, at least some of the things that we have completed. Git, to some extent, we have completed. We know exactly how to push
Mhm.
changes, how to clone a repository, how to add a change to the staging, and how to commit, and how to push. Correct me if I'm wrong.
Mhm. Okay.
And in GitLab, we know exactly how to create a repository, how to create a project, how to create a group.
So here we are not using Jenkins, right? Only GitLab.
Yeah, we are using GitLab.
Are both same or what, sir?
Yeah, it is same. Jenkins is only the CI tool, similar to what we are currently using in GitLab, right? Like build pipelines, settings, CI/CD,
Yes.
all of those things will be written in Jenkins. That will be Jenkins file instead of .gitlab-ci.yml file. It will be Jenkins file.
Oh,
And we have seen almost 80% of Terraform. Terraform will be completed in the next, I mean, by this week, end of this week, Terraform will be completed. All the resource creation, modification, deletion will be through pipeline, it will be completed. So in the GitLab also, we have to see CI and CD. How to run CI, continuous integration, how to run continuous deployment.
yeah.
And we'll be looking into Docker right now. After Docker, we'll be looking into Kubernetes, and then we'll be looking at monitoring tools.
Are we gonna study any Kubernetes tools?
Yeah, a little bit introduction about Kubernetes at the high level, some architecture, some different YAML files, uh, how how we can create Docker containers using Kubernetes.
Okay.
So containers are not virtual machines. Containers are a smaller subset of uh, a virtual machine which contains only the required binaries and packages. You understand what is a process, what is a service, right?
Yes, sir. Sir, actually, to be
Yeah.
honest, what are these containers, Docker containers, for example? I have a basic understanding, sir. Okay, so it will be like a container. It will have all the dependencies, everything related to an environment, to run an environment. It will have everything in it. Just we have to use that and do our work or something. This is the basic understanding I have. If I'm wrong, please correct me, sir.
Yeah, that's a good understanding. Uh, so why we started with containers? That's very important.
Hmm.
For that, you need to know why we started with virtual machines, right? We wanted to have consistent environment, consistent a machine, right? I mean, consistent resource. Say, for example, your laptop may be having some softwares installed. Uh, sorry. And the same kind of a laptop which is holded, which is held by other people, right?
Mhm.
Maybe it is exactly the same environment, but the operation wise or the performance wise, it will definitely look very, very different, right? You
Correct.
cannot ensure that the same way you are running, he can run it or she can run it. So there'll not be a consistent performance across different laptops. The same version, same hardware, same configuration. So people started a couple of things. I mean, one is consistency, another one is resource utilization. Say you have a big machine and then you are not utilizing the resources correctly, then also it becomes a question that, I mean, how we utilize the complete resources, complete available resources effectively. That's when we came up with virtualization and virtual machine and VMware or Oracle VirtualBox. So there we can, by installing hypervisor, we can create virtual machines, and then virtual machines can run uh, on the host operating system. However, it became very difficult to port to a different machine, uh,
Mhm.
and it becomes heavyweight. It's maybe 1 GB or 1.2 GB. It's in GBs, not in MBs, most of the times. And if you are running a single process, I mean, if you're running a particular service uh, on a single virtual machine, only you can run single process. You cannot run multiple processes of the same. Say, for example, you are running HTTPD service, HTTP service, right?
Should Yeah.
This service you cannot run multiple versions because it will be treated as a single service in the
Mhm.
machine. You can have only one package, and that package will have HTTPD as a service. Once it is running, it will be occupying port 80, right? And if you run another service of the same, it will say port 80 is already occupied, HTTPD service is already running. So that becomes a bottleneck because even though you have a very big machine, uh, very big virtual machine, but you are using only part of the resource because you are not able to run multiple versions of the same service, and it is very difficult to move to different locations, another physical machine or another server. It is difficult because it is big in size, and it will take a lot of time and a lot of resources to transfer from one place to another place. And every time you end up installing the complete operating system with a kernel. So that itself says that it is probably consuming on your physical machine, it is consuming about 30 to 40% of your resources. Single point of failure, it's all about if the system goes down, all the services which are running inside, right, goes down. There is no way you can get them back. You need to restart the machine. You need to fix all the issues here, issues inside. That you need to fix it. Then only you will be able to run the machine and then get these applications running. So that becomes a problem. So that's why, uh, see, it's all about running a process, right? I mean, when we talk about servers, it is all about running an application or running a service or running a process. Here, everything is isolated. How it is isolated? By packaging only the required softwares, required binaries and libraries. Since it is isolated and it is taking only the required binaries and libraries, right? It can be portable anywhere. It is lightweight in nature. It's hardly 100 MB, 60 MB, 70 MB like that. There are containers which are heavy in size, but most of the times it is very lightweight. It is portable everywhere. See, one of the most important thing is it it takes only the required binaries and libraries. Uh,
Container.
and it uses a kernel OS kernel host kernel. It doesn't require the complete kernel to be installed for every small operating system that you create using container.
Sir, actually, who edits this Docker containers? Is it us or is someone allocated separately to edit those, make
Mostly,
changes?
the doc file is written by developers.
Uh-huh.
We don't need to really write Docker files, but for some changes similar to Sonar Cube integration, some changes related to build, uh, we will have to modify the Docker file, and ultimately you will understand every piece of code in the Docker file because it is set of instructions. It is all about what is the base image,
Mm-hmm.
where exactly, what are the different commands that you are running, what are the different packages you are installing. Hope you are aware of how to install a package in a Linux machine. You using yum command, right? Yum or apt command to install a package. The
Oh,
same,
yum install. Okay, okay, yeah.
yeah. Similarly, a Docker container uh, can be a Windows machine or a Linux machine. Uh, but when you are running a Docker container, irrespective of whether you are running it on Linux machine or Windows machine, you will be able to run those commands. If you are deploying a Docker container, which is Amazon Linux or a Ubuntu machine, Ubuntu operating system, right? So you can run yum install so and so package, vim or telnet or httpd, any package you can install, and then uh, start your required processes. And one important thing is if you are building a Docker container on Windows, it is not portable to Linux machines. Similarly, if you are building a Docker container on one operating system, that cannot be ported to another operating system. I mean, Windows and Linux only I'm talking about. Because it uses a host kernel. It doesn't it doesn't have its own kernel. You have to build the Docker container with a host kernel. So whenever it runs on the machine, it goes and checks what is the kernel of the host operating system. If that matches only, your container will be executed. Otherwise, your container execution will be halted.
So the base operating system should be same.
So only there are two, Linux and Windows.
Windows.
If you are building it on any Windows, it can be installed on deployed on only on any of the Windows machine, Windows operating system. The other one is Linux. That includes Mac, HP UX, um, Amazon Linux, or any hardware for that matter. It is kind of portable.
So most of the time, which OS is used worldwide for this
Linux.
Linux?
In the
Oh,
container world, it is most of the times Linux. So inside the container, you can run yum command to install the packages. So as I said, runs on Linux, not on Windows, and vice versa. So run multiple versions of the same application. That is, like you can run HTTPD service by exposing to a different port. You can run multiple versions of the same application on the virtual machine. And yeah, maybe you will say there is a keyword called expose. Using that, we can expose port number 80 to be a container port, 80, 81, or 82. Say, for example, 82 as your um, host port. So host will understand it has to talk to 82. The container which is running, which will actually forward a request to 80. So from the host side, from external people, for the external people, only 80 is visible. 8 sorry, 82 is visible, and 80 is completely blocked. So only the container which is running knows it has to talk to 80 and then get the response back to the customer. That is how it is designed. I mean, Docker port, I mean container port and host port. Only the host port is visible to the external customers, and they do not get to know what is the port which is running on the Docker container. Like that, say for example, the same application can be run on 84, or you can say 90, and you expose only these ports to outside world. Whereas the application will be running on port 80 internally in the Docker container. So this example I'll give you in the upcoming classes so that you can understand. You can try to map it. I mean, I'll probably come back to you and then explain this particular piece of line. And ephemeral in nature is all about containers cannot be, you cannot run it for multiple, you cannot run it for multiple days, or you cannot run it for longer time. Because over a period of time, say for example, you are using your laptop without cleaning up anything. You are keep on storing a lot of files. You are keep on running your laptop with multiple browsers, multiple tabs, like hundreds of tabs. If you open, what happens to your laptop? It gets hang, right? It
Lag,
gets
yeah. Too much of
too much of
cases.
lag. So if they, for example, you are keep on downloading video files, some movies, and then keeping that stored in a C drive or D drive, automatically your disk space will full, and then you will have a problem in accessing your file system. Similarly, Docker containers are small piece of code. It's an isolated environment which contains only some resources, not all the resources of your system. So when you are running the process, there are chances that it might get filled up with disk space, or maybe too many people are accessing the container, and then it becomes overutilized. In that case, it will be killed or stopped at any time. So that's why you have to manage Docker containers. That's when orchestration comes into picture. That's when Kubernetes comes into picture. We have to create a cluster. In that, we have to have multiple EC2 machines, and your containers will be placed in multiple EC2 machines based on the requirement, and it will be highly available. Um, so we'll see those things when we move on to Kubernetes container orchestration. But at a high level, if you can understand what is Docker, it is enough. Docker actually say a lightweight, standalone, and consistent environment we have already seen. Docker also simplifies application deployment by creating consistent environments. How it is creating consistent environment? Because Using the Docker file, you can define all the requirements. In the Docker file, you can define all the requirements. All the requirements will be compiled every time, and then it will create a Docker container. So if you run second time, it will again create a similar Docker container with almost same whatever it is there in one, it will be running in two. Like that, you can create multiple containers either on the same machine or on a different machine. That's up to your requirement how you are creating it. So that's why it is very reliable. You can easily say that okay, whatever is running on this machine, it is running on this machine as well. So that is why it is very reliable. It is very consistent, and you are not going to run anything extra on that particular container unless it is required.
Okay. And in Docker file, is there any particular template, like it should be in this way itself in order to execute? For example, in Cloud and all, we have this JSON format.
Yes, yes, it is. Docker file is a simple text file, but there are some instructions that you need to follow, some format that you need to follow. We'll definitely see that.
Okay, okay.
Yeah, definitely that is important. I'm just trying to give you high level introduction of Docker containers because before we move on to uh, uh, the GitLab CI pipeline, right, you have to have an understanding of what is Docker file, what is Docker container, why Docker containers are required. On a physical machine, you can run a Docker container, multiple Docker containers to run your jobs, to run your processes. Similarly, in the GitLab, we have GitLab runner that we'll talk about it. I mean, after this, okay, we have seen isolation, portability. That means, I mean, you can run the same container on different machines. Efficiency, we are just trying to use existing kernel. We are not installing kernel every time. We are just host machine's kernel is used when you are running the container. Consistency, as I told you, it can be deployed in multiple places, multiple systems without compromising the quality, and it'll be the exact version of the same container running on different machines. Size is very small, boot time hardly few seconds, so container uses fewer resources. The only other thing that we have seen so far, so for example, when containers means the running version of the container or running version of your Docker is called containers. Images are the packages, the ISO images, which is nothing but a Docker image, which will be used to run the Docker container. From the image itself, will be able to run the Docker containers using Docker run command. Docker file is a basic one, which is a base for creating the Docker images. In this, we have written all the instructions, what image we are pulling, what are the dependencies, what are the different commands that you are running inside the before creating the image. Everything will be mentioned in the Docker file. Docker Hub is a place where you store images over the internet. So you can store Docker container images like this one by one. That can be pulled and executed to run the Docker container. This is pushing. This is pushing. And when you want to run the container, you are pulling the container and running it. It is similar to your Docker, sorry, Git pull and Git push. When you do a Docker push, it is going to the Docker Hub and getting saved. So whenever you build an image, you can also push it to the Docker Hub and save it. Whenever it is required, you can pull from the Docker Hub and then run the container. Docker volumes, it is important because, like I told you, Docker containers are ephemeral in nature. It deletes everything once the Docker container is killed. However, we can restore the volumes by having, say, for example, there are Docker containers which are running like this. And we can have a smaller portion, that is volume, attached to the Docker containers from the host operating system.
Sir, is there any minimum time duration and maximum time duration? No, right?
No, 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 nothing.
It's just like our EC2. Whenever we want, we can start. Whenever we want, we can terminate.
Exactly, that's exactly right. It is something similar to EC2, but we have a control over EC2, right? For Docker containers, we don't have control.
Con-
Nobody can guarantee that whatever Docker container you started will be running for this many hours. So it can be killed at any point because
by,
of
any, by anybody or
no, not by anyone. If you're probably putting a lot of stress on the container, say if you're accessing so many resources, if you're trying to do so many operations, so that might probably affect the container which is running. So that might be killed. Say for example, EC2 machine also, if you're running a huge number of resources, if you're really putting a lot of files into that, right? So automatically it's filled and then your machine is not accessible.
hmm,
That happens over a period of time. Similarly, when you're running a Docker container, you have to make sure Docker container is running fine by just checking whether that particular port number is open, that particular service is running or not. So you have to do frequent checks to make sure the application is running fine, the Docker container is running fine.
not like our EC2 has this auto scaling just
Yeah.
to manage and monitor.
This also we can configure auto scaling, but for that you require Kubernetes kind of softwares,
Oh, wow.
container operating system.
Orchestration of containers.
Yeah. Container orchestration is done by Kubernetes. So people also call it as container operating system, Kubernetes. So because I mean it manages the complete uh, Docker ecosystem or the container ecosystem. Here I've written down comparison of virtual machine and containers. It is exactly the same we have seen so far. I'll share these slides with you. You can go through it. So here, this is very important. Say to run a process, what we do, like we do systemctl start the particular process, right?
Yes, yum install
So
system
we
CTP.
start to check everything. We are doing the systemctl commands, which is nothing but a built-in system commands or built-in process command for running the process. To stop the process, we use kill command. So what I'm trying to explain here is a process in Linux is nothing but a program in execution. That means unless a service is running, it cannot be called, unless a service is running, a process is running, it cannot be called as it is running and it can be accessed by people from outside. from the internet. So processes are the fundamental thing in the operating system execution, allowing multitasking and resource management. So unless a process is running inside a physical machine or virtual machine, the machine cannot be accessed by anyone from outside world. For example, you are accessing SSH, right? In EC2. That means there is a service called SSH is running. If SSH is not running, you cannot access the resource. Only if it is running, if it is not running, you cannot access the resource. If it is running, you can access the resource. So like that, processes are the um, fundamental thing in the operating system to allow people to access your resources, allow people to access your machines. There are different protocols and port numbers. You have already seen about it. I mean, the basic uh, default port numbers for HTTP, default port numbers for SSH. What is the protocol being used? Either it is TCP or UDP. So SSH is running on port 22. SHD is a service name. For HTTP, it is port 80. How to check locally from the uh, command line? It is using curl. It is nothing but command line URL. Command line browser, you can call it as. You can just use the same URL which you would access from the browser. You can put it over here. You can get the same response. So this, if you look at it, Docker containers uh, are all about running an application, right? Like I told you, it uses binaries and libraries. Say if it is a Docker, Docker is called a Docker engine. That is a basic which is required to run your Docker containers. Docker engine should be running. That is nothing but Docker D. Docker D as a service. So you can
Where
run.
will it be, sir? Will it be inside containers or on our system?
It will be running on your system.
Do we have to install it or
Yeah, we
just
have to install it. We have to install it.
Docker engine?
Yeah, Docker engine is nothing but Docker D, Docker daemon. That is a software which is running in your system to ensure Docker containers can be deployed. Docker containers can be running on your machine. That's all. It is like again the base for your Docker containers.
Yeah, sir. We have learned about this daemon and all,
Uh,
so we can relate. Yeah.
Host operating system is all about your operating system. Just a second. Okay. So infrastructure is all about your hardware and everything. On that, you are running the host operating system. On top of it, you are running the Docker engine. Like that, you are Dockerizing your environment. So you can run multiple containers. Here we have just seen only ABC. There are hundreds, hundreds of containers will be running on a single virtual machine. The, nowadays, all the uh, big companies are running their workloads on only on containers, not on uh, not like a standalone application. It is all everything is a containerized application. Everything is a Everything is based on Docker or maybe other containers.
So will it have so much of capacity to handle hundreds of containers?
Yeah, say for example, your machine is around 4 terabytes or 2 terabytes of hard disk and maybe 1 terabyte of RAM, 1 TB RAM.
1 TB RAM.
Not 1 TB. Okay. What normally how many GBs RAM you have? Okay. Say
16.
so 16 GB RAM for your laptops, right? And when you go for servers, right, it'll be 1 TB.
Oh,
If you go for big servers, it'll be 1 terabyte.
you mean
I have like
supercomputers? Like that?
yeah, yeah. Even if you think about normally nowadays we have 16 GB, 32 GB in the phone itself we have, right? 16 GB and 32 GB. But so like
Oh,
that, there are high-end machines available. So in that, even if you think about your laptop, right, you can run about 40 to 50 containers.
oh, is it?
Yeah,
Oh, minus 16 GB, sir.
yeah, yeah. So depends on the size of the container that you are running. Say if you are running a very small container like 256 MB RAM and things like that, you can run. If it is 256 MB, sorry, 256 MB, that'll be four containers for 1 GB. So 16 into 4, around 40 to 50 containers you can run it on your local. If you create a virtual machine, and how much is the virtual machine capacity, based on that you can run it.
Okay, sir. Clear.
Okay. The Docker architecture, we'll just finish it up with this. Client is all about running Docker build, Docker push, Docker run. I mean, the Docker commands, whatever you are running, that is a client. Docker daemon is a Docker host. I mean, if Docker daemon is not running, if it is not running, it will not behave like a Docker host. So you cannot run Docker build, Docker run, Docker push, whatever command that you want to run, it cannot be executed because your Docker daemon is not running. It is similar to Docker daemon is similar to uh, if operating system itself is shut down. Similar to that, you cannot really log into the machine, right? Similar to that, if Docker daemon is not running, Docker containers cannot be running. And Docker hub on the right hand side, Docker registry is to store and retrieve images at the runtime. Some of the examples like Nginx, OpenStack, HTTPD service, anything for that, you can take an example.
What are these? Sorry,
Which
OpenStack.
OpenStack
OpenStack.
is another software that is used for uh, private cloud. It is similar to your
Okay. Our AWS
uh,
is hybrid, right? So OpenStack is private, is it?
yeah, it is mainly used for building private clouds.
Okay. All right.
Okay, with this, I'll close the today's session. I'll end the show for now. I'll share these slides to the group. You can go through it.
Yes, sir. Yes.
Sure. Okay. Thanks, Akshay.
Thank you, sir. Tomorrow.
Tomorrow, same time, 7 o'clock, we'll try to finish it off the GitLab CI and Docker containers this week so that will have a evaluation session next week. Assessment.
Okay.
But
Kubernetes.
yeah, yeah. We'll have the one more. I mean, we have another 2, 3 weeks time to go over different uh, I mean, we still have 2 to 3 weeks to complete.
Mhm. Okay, sir. No.
Okay, sure. Okay, Akshay. Bye.
Thank you, sir. Bye. Have a good day.